sometimes. Section lesson 3.4. Big idea here is slope of a line. We've talked about this a little bit. We usually use that letter to stand in for the word slope because math people are kind of lazy. They don't like to write a lot. Slope is often we consider a rise over a run. That rise is some kind of vertical change, could be up or down. And the run is a horizontal change. Now, something I didn't mention last couple of class is, and when we look at a change in something like, how did my weight change from last week to this week, or how did my money change from last week to this week? We're doing a subtraction to make that happen. So there is a formula for change, and it's usually the new number minus the old number, which we call the new one y2 and the old one y1. And I'm using y's because that's my vertical. And then x is my horizontal axis, so that would be the new x value, which we usually give a higher number like x2, minus the old one, which would be x1. So that is a slope formula you may have seen before. Does it matter which one I call x1 and x2? The answer is yeah, it does, especially when we have to call y1 and y2 something. So let's pick on Marcel here with this in mind. So Marcel, let's use red to make that stand out. Marcel connects those points right there. And I just want to identify these 2 points. If that's week 1 and that's week 2, then back here, that must be week 0, which is when they started. And then a week goes by and a second week goes by and so on. So this point up here for Marcel would be the point 0 to 100, right? So that's his starting weight. The starting point for an equation, a linear graph, is often called the y-intercept, right? So my y-intercept is going to be the point 0 to 100. So that's going to come up in an equation. And then I have this other point over here, and that was 3 weeks later. So 3 is the horizontal value, and then 190 appears to be the vertical. Now, I can just look at this and kind of see what's going on. I don't really have to use that formula when I have a graph, but I will in just a sec. When I look at this graph, I can clearly see that Marcel's weight dropped, right? It went zoom down to there, and that happened over that 3-week time period. So just looking at that, I can imagine the rise, which would be a -10 for the rise. And for the run, I can see a 3 there. So just looking at the graph, I can say, well, it looks like he lost 10 pounds over 3 weeks. All right, my vertical value is pounds, and my horizontal value is measured in weeks. Now, comparing that to the formula I have here, where I'm going to say this one right here would be my 0.1, and this one right here would be my 0.2. So that means if this is 0.1, that's x1, that's y1. This is 0.2, that would be x2 and y2. So applying this formula, y2 was 190 minus y1, 200, over x2 was a 3, and x1 was a 0. So we had 190, we lost 200, that's a net loss of 10. And then had 3, lost nothing, so we keep 3. So there's the same numbers I saw in the graph. So a lot of times graphing things helps me wrap my mind around stuff. So I'm often going to graph numerical information if I can like this. And then the question is, well, what do I do with this number 10/3? So you could ask Marcel, hey, Marcel, how'd your weight loss program go? He says, man, I'm averaging losing 10/3 pounds per week. It's like, oh, what? 10/3 pounds? What do you mean? So this is a nice number mathematically, right? Can 10/3 be reduced? The answer is no, because 3 does not go into 10 evenly. However, I can divide and get a remainder, right? So I can say 3 goes into 10, do a little division, how many times? Well, 3 times 3 is 9. Subtract and I get a 1. So I can see that 3 goes into 10 3 whole times with 1 out of 3 left over. So negative 10 thirds, I could also say is negative 3 1/3. So I asked Marcel again, hey, Marcel, how's your weight loss program going? He says, man, I'm averaging 3 1/3 pounds per week off. Like, whoa, that's pretty good. Nice job, right? So when we're talking to each other, we tend to talk in mixed numbers, right? So this is what's called a mixed number. Mixed numbers are common when we talk to each other, right? Common in speech. 10 thirds is a nice number, or negative 10 thirds is a nice number. It's called an improper fraction. And it turns out if you have to do math with a number, it's way easier to do math with improper fractions than it is with mixed numbers. And so these are more common for calculations. So you could ask me, well, which is the best answer here? Is negative 10 thirds the better answer, or is negative 3 1/3 the best answer? I would say, well, it depends. What do you want to do with the number? Well, I want to tell my mom about it. Okay, well, then tell her negative 3 1/3. If you said, well, I need to do some math with it, then I would say, okay, negative 10 thirds is the better answer. Just depends. They're both good answers. Another thing to think about with these slopes and numbers and negatives in particular, I wrote my number as negative 10 divided by 3. Now, you might remember from your work in math before that if you take a negative number and divide by a positive number, you get a negative answer. So I could also say this is negative 10 thirds, right? So the first time I said it's negative 10 over 3. The second time I said it was negative 10 thirds. Now, just like a negative over a positive has a negative answer, a positive number divided by a negative number also has a negative answer. So just as an improper fraction being negative, there are 3 ways to think about it. That the negative belongs to the numerator, not the denominator, that the negative belongs to the denominator, not the numerator, or you just got a negative fraction. So just a little review about fractions and negatives there, because that's going to be helpful with the slope idea here. And I'll demonstrate here that in my messy picture. Actually, I think I'm going to erase some of my messy picture. Let's let all of that go away. And let's go back to red. And I'm going to think about this number as my slope, the way I would tell my mom, the way Marcel would tell his friends about his weight loss progress. If that's a slope right there, then that slope has to have a rise. That was supposed to be an R. Let's try that again. There we go. And it's supposed to have a run. Now, I'm going to say the rise is negative 3 1/3. So to keep the number the same, I can only divide by 1. And we'll do that sometimes. So a rise of negative means it's actually a drop. So if from 200, I dropped negative 3 1/3, okay, so the distance from here to here is 5. So 2.5 would be in the middle there. 3 1/3, I think is going to be about a drop to there. And then over 1 week should put me at that point right there. So right in this little red triangle, I tried to do a drop of negative 3 1/3 and a run of 1. Notice that puts me on the same line. Now this fraction right here, let's maybe do that one in green. It said to drop 10. So from here, dropping 10 takes me to there. And then a run of 3 takes me to there. So any version of the slope I use from a particular starting point should keep me on the line in question. Now check out, let's use a highlighter here. Let's check out this one right there. And now let's use a green. This is more exciting than red. This one says go up 10, left 3. I'm going to pick this as my starting point. So this is up 10 to there, and that would be negative left 3 puts me back there. And if I did that again, guess at up 10 and go left 3, that should put me on the same line there. So with slopes, I can go in either direction on the line, and I can go a far way, depending on how I write the slope, or I could go a shorter way, depending on how I write the slope. We're going to keep getting used to that idea this lesson and the next one. All right, slope overview, back to the lesson. So in this context, what would the rate of change slope mean? What does the vertical intercept mean? Give an answer and then compare it to ours. So once you hit submit, you'll see what our answer is, me and the other teachers who do this. And just back to my notes for a second. When I was thinking about what the slope meant here, I did this calculation looking at the picture that Marcel lost 10 pounds over 3 weeks. So the slope is gauging his average pounds per week. And then he had to start somewhere. So that kind of answers question 1 right there. I'm going to pause there for a moment if you haven't already answered this question. And I think I want a new version of the graph to do that because I messed up my other one. There's lots of writing. So let's pull that into a new screen. Okay. And you have 2 options here. You can write down the points for each one and use that whole y2 minus y1 over x2 minus x1, which is an excellent way to do this. I already did one example of that. I'll do another one in a moment. I can also look at this and figure it out. So I'm going to go with the look at it version. I'm going to grab this table, put them in the same order. Pull that over here. So let's see, we already did Marcel, right? And looking at Marcel, we found that there was a drop of 10 and a run of 3. So for Marcel, there was a drop of 10 divided by a run of 3. For, who's next? Jonas. Now Jonas actually went the other way. Jonas went up 10 and over 4 weeks. Oh no, I lied, I can't count. Jonas only went up 5. So Jonas went up 5 there and across 4. So up and right are both positive, so that should just be 5 over 4. Jamie, what happened with Jamie? Jamie looks like Jamie dropped 5 over 4 weeks. And Carly just stayed the same, right? There's no up or down. So 0 is the rise over 3 weeks later. And then can I clean these up? You know, not really, right? 5 and 4 have no common factors, so you can't reduce it. Oh, do I have an error here? I do. Jamie was a drop. So that should be a -5, right? Because this one is downhill. So just another note on slopes. Marcel and Jamie, both of their graphs go downhill. From right to left. No, let's see, that's right. This is left, from left to right. So I'm a little left-right challenged. From left to right. And they both had negative slopes. And negative slopes always have that property. If you have a negative slope on the graph, you should see it going down from left to right. If the slope is positive, it should be going up from left to right, like Jonas had that positive slope there. And then Carly's neither up nor down, it's just flat. That's a slope of 0. So we could write that one simpler. To double check some of these I pulled off the graph, we could look at Jamie for a minute. And Jamie had the points 0, 185, and 4, 180. And then I could say this is x1, y1, x2, y2, and then apply that formula, y2 minus y1. That's a little messy. y1 over x2 minus x1. So then y2 would be the 180 minus y1 is the 185. And then x2 would have to be the 4 minus 0. So 180 take away 185, that's a negative 5. 4 take away 0 is a positive 4, and that matches what I had just looking at the picture and drawing on the picture. Does it matter if you get the points in the wrong order? Yes and no. If you're consistent, it does not. So by that, what if I started with the 185 first and then subtracted the 180? Well, since I wrote that number first in the top, I would have to write the 0 first in the bottom and then do a minus 4. And the important thing is that the y's are in the top and the x's are in the bottom. And then the third thing to get the slope right is your points line up vertically. So here I can see the point 4, 180. And down here I see the point 4, 180 stacked on top of each other. Here's the point 0, 185. If you got that in the wrong order, then you'll definitely get the wrong slope. Watch what happens when I continue with this red one. 185 minus 180 is a positive 5, but 0 take away 4 is a negative 4, and negative 5 over 4 is the same number as 5 over negative 4. So I'm still okay. As long as the y's are in the top, x's are in the bottom, and then your points line up vertically, you'll always get the right slope. Okay, moving on. So we have our slopes. And when you click on these boxes, pay attention. So here it says enter a fraction or an integer. An integer is kind of like a whole number or a negative whole number. Fraction's a fraction. And you can use their fraction button, or you can just type divide. So like, what did we have for Marcel? Marcel was the negative 10 over 3. So I could just go over here and type negative 10 over 3. And just use the slash on my keyboard to divide. Or you could use the fraction button, your call. How are these units measured? Well, earlier we decided these units are measured in pounds per week. Now, I mentioned this in my discussion a moment ago, the relationship between the direction of the line and whether the slope is positive, negative, or 0. So I'll give you a moment to answer those questions if you haven't already. So the last few questions are all about Jamie. So what do we know about Jamie? So we can see Jamie started at 185. We saw earlier that Jamie had a drop of 5 pounds over 4 weeks. So since we know the start and we know the slope, then we know the equation for Jamie's progress. Now, often I like to write y equals mx plus b. X is our independent variable, that's weeks, and the y is our dependent variable. And often we'll pick letters that better represent the situation. Like instead of y, we'll call it w for weight. So let's take a look at what the problem asked us. Problem said to use W and T. And when we click on the box here, it's going to remind us what our variables are. So T is weeks, W is weight in pounds. And I always like to write that down in my problems too. So we're going to use a W equals the slope times T plus B. And W is our weight in pounds, and T is the number of weeks in this weight loss program. So that's kind of already written out for me. Sometimes I like to write it explicitly. So if this were, for example, a share your work problem, I would expect you to see you write out what each variable means and then plug in what we know. Well, we calculated the slope earlier. Our m is negative 5 over 4. and that's multiplied by the t. And then the starting value is Jamie's 185. So this right here should be Jamie's equation. Now, dividing by 4 is nice. It works out good. If you plug that into your calculator, you're going to get negative 1.25 pounds per week. So I could write it this way. If the decimal gets weird, like it fills up the whole calculator screen, then I'm probably going to stick with the fraction instead of the decimal. So I like that answer better, but this one is okay too. So that's Jamie's equation right there. I like this one. And then I'm asked a couple of questions. What is Jamie's weight if she continues this progress? What's it going to be 5 weeks later? So t equals 5. And that's pretty easy. I can just plug into my equation. And usually when I plug in, I'll put parentheses around it to be safe and then figure out what to do. Let's see, 5 over 1, multiplying fractions, you just go numerators, denominators. Negative 5 times 5 is negative 25. 4 times 1 is 4. And now's a good time to grab a calculator. And I've been liking Desmos lately. You guys have seen me use that in class. I like the scientific version. So I wanted to take negative 5 over 4, move out to the right, then times 5. It's important we get that in the right spot, and then add that to the starting weight of 185. And I get a fractional weight of 178.75. I could get it in fraction mode, but would we really tell somebody, hey, I weigh 715 pounds, right? No, we wouldn't. We'd go with that one. So they both have their pros and cons. This one's better for communication. I'm going to go with that for my answer, 178.75. And let's see, I can plot that 5 with that number right there and see if it looks good on the graph. So here's 175 here, 180 is here, 178 is close to like 0.75. That's like 179. That's just a little lower here. That would be around there, which seems on the trajectory of this line. I'll buy that. Looks good on the graph. So that's a good double check. And that would be pounds. So I could say after 5 weeks, Jamie's weight is predicted to be about 179 pounds. And then I was also asked, Jamie had a target goal. I believe it was 173 pounds, and we want to know how long it will take her to get to that. Is Jamie a she? Yep. I have a friend named Jamie who's a guy. You never know. So let's see. Yeah, target weight was 173. When will that happen? Okay, so they give us the weight. We have to find the time. That's always a little harder. So let's go back to the notebook and whip it out. And if you've already done this, feel free to move on. Fast forward. All right, so again, we have Jamie's weight is negative 5/4 t plus 185. Yep. And we want to know when the weight is going to be 173. So we drop it in there and solve. And to solve an equation like this, we've done a few of these over the last couple of weeks. When you're plugging into equation, you multiply then add. When solving equation, it happens backwards. So we're going to get rid of the add by subtracting. So that cancels if we did it right. On the other side, let's see, 173 to 185 is 7 and 5, that's 12 pounds, I think. But negative on the other side, negative 5/4. I'm going to plug this into the calculator to check. And the easiest way to get rid of a fractional multiple is to multiply by the reciprocal, flip it. So on this side, I'm going to multiply by negative 4/5. Do the same thing on this side. And that should be my answer on the calculator. T equals, let's check it out. So I'm gonna make sure I get the subtraction right, and then I'll do that multiple. So put it on paper, then hit your calculator. If you're in the practice of just doing things on your calculator and not writing things on paper, again, it's hard to kind of proofread what you did there. So I had 173 minus 185. Oops, wrong button. That button. Negative 12, just like I thought. And then I want to take that negative 12 and multiply it by the flip of the slope. So that would be, I'm going to do parentheses to be safe. And I called it negative 4/5. Oops, parentheses in the wrong spot. And it looks like it's going to be 9.6. 9.6 what? Well, let's look back at what I was doing there. T should be weeks. All right, so this came out to be 9.6 for T, and T we wrote down earlier was measured in weeks. Let's just double check that that's true. To do that, we just go back to the original equation and plug in. So I'm gonna take that negative 5/4, oops, and I'm gonna multiply it by 9.6 and see if I get the 73. So I can use my calculator for that. So negative 5/4 times 9.6 is, I believe, the amount of time for Jamie to get to her target rate if she keeps up the same pace, plus 185. Yeah, there's the 173. So I did okay there. So again, find ways to double check yourself before you go and push a button. All right, we're going to stop here for a moment.